The combination of SNAP and Microblocks makes it possible to acquire and graph sensor data from the microbit. In this demonstration, we're going to use a potentiometer to vary the input to pin 4, but this could be any number of sensors. It could be a microphone, it could be a light sensor, and a temperature sensor, or any kind of other type of scientific probe or sensor. When we begin graphing, we just start the turtle moving across the screen, and the pin value is reflected at the bottom. We have a couple of possibilities for varying called gain and offset. Now, the offset determines how far up or down the screen the line is drawn. So if I want to decrease the offset, I move it to a greater value, and if I decrease the offset, I move it to a lesser value. The gain determines how far up or down the graph goes. So if I have a big gain or amplification, it will actually go off the charts here. I'll need to recenter this using the offset. And if I have a smaller gain, then the excursions are graphed up and down. Now, as in a different way, I have to move the offset back down now. And this doesn't change the data, it just reflects how it's shown on the, with a gain of 0, I'll get nothing, of course. It just shows how far up or down it goes on the graph. Now, this is comparable to the strip chart recorders that were used with paper before computers were available. The gain would be connected to an amplifier that showed how much the signal was increased or amplified, and by increasing the gain, the strip chart recorder would have a greater excursion. The offset made it possible to center on the screen. Once we began moving from strip chart recorders to oscilloscopes, essentially the same controls were carried over. And now today, we essentially have the equivalent of an oscilloscope, but we're using the computer to display and graph the data. One advantage of a computer is that we can store the data and then analyze it later in different ways.